See, last class we just observed how the rope is loosening and how the rope is getting tightened. Yes or no? In that case, we have learned about the constant motion, right? Let go for constraints. Take a lecture 2 on constant. Okay. Student, that means we are trying to know the displacement, velocity, and acceleration of the blocks as well. Yes or no? Let this is the triangle. This is the surface, right? So there is the pulley, right? We have already done such type of questions. Let this is a block A, right? And it is going like this. Let there is another block that is B. That is A block, that is B block, right? See students, audible all?
Yes, sir.
Student,
Yes, sir, audible.
let this is block A, this is block B, right? Let this angle is some alpha, let some angle is beta. I'm not solving the numerical. That's just saying you the concept. So just let this rope length is SA, right? The rope that is on the A side, okay? And this rope length is SB, right? On the B side, okay? Let on the pulley some part of the rope is there. Let that part is C to D, right? Understood up to this? I'm just concerned about the length of the rope, right? Hmm? Yes or no, students? Student, whatever. If this block is coming this side with some acceleration, then this block will go upward in some acceleration. Yes or no? We have already discussed such type of questions, right? Whatever, how much maybe the block get displaced, but we can see the length of A as a rope length plus length of the rope that is on the pulley plus length of the rope on the B side will remain constant, student, right? That is that length, and that length of the rope is constant or not?
Yes, sir, constant.
Length of the rope is constant. That length is L, right? So I'm writing. Okay. Students, if it is constant, if somehow with time the displacement of A change, then the displacement of B will also change. The length of SA will change and SB will also change. Yes or no? If this block is coming somehow to this position, then this block will also go to the upper position. Yes or no? If this block is coming in this direction, then this block will go that much extent to upper position. Yes or no, students? Yes or no? Let differentiating with respect to time, the relation that we got, we want to differentiate that one, right? Differentiating with respect to time, how the length is changing, right? Then what can we write? This is very small length, neglect that one, no problem. So we can write dsa by dt, means at a particular interval of time, how much distance the A block is moving, that is equal to dsb by dt. Understood everyone? How this length is changing? The rope that is on the S, the length of the rope that is connected to the A block is changing, right? The length of the block rope that is connected to the B block, that will also change. Yes or no? Getting Purav? So ds by dt, and that is equal to L, but L is remaining constant. And what is the derivative of constant, Srishti? What is the derivative of constant? Zero, right?
Yes,
So that means how the length of the rope will be changing. That will give me what? That will literally give me velocity of block A plus velocity of block B is equal to 0, right? Yes or no? And velocity of block A is equal to minus of velocity of block B. Yes or no, students? Velocity of block A is negative to that of velocity of block B, means what? If it is going in this direction, yes or no? Negative sign indicates that when the block A has a velocity, let A block is having a velocity upward, then block B will be having a velocity downward, right? Yes or no? That is the significance of this negative sign. Getting or not, students? Understood? Let I will differentiate velocity with respect to time. dVA by VB is equal to derivative of VB with respect to dt, right? Then I can get acceleration of block A will be equal to negative of acceleration of block B. That is clear also to all? Yes or no? Students, if anyhow in any of the constant, in any of the mixed pulley, mixed constant, if I'm able to relate how the rope length is changing, then my work will be done how to relate the velocity and the acceleration. Getting, students? That day I just told you about the observation, how much the rope is going up, how much the rope is going down. Last class, that the 2 to 3 problems that I had done. Do you remember? I have uploaded that video today, right?
Yes, sir.
So just revise those. Just make a diagram of pulley in your mind and see how the rope is loosening and how the rope is getting tightened on the other side. That is going to decide how the displacement is changing. Displacement will lead to velocity, then the velocity will lead to acceleration, right? Understood or not?
Yes, sir.
The main objective in many of the cases will be how the length of the rope is changing on both sides, right? Yes or no? Student, based on this, I will give some examples on mixed constants. Then we'll do 1 or 2 questions today, right? Just update the notes now. We'll see mixed constant की another concept. ठीक है, ring sliding on a smooth rod. Give heading ring sliding on a smooth rod. ठीक है. I want to just relate the things because it's not a question, it's a concept. Yes or no? You'll be getting such type of questions. In that case, you have to relate so many things. Okay, that's the concept is like this, student. This is the horizontal support let, yes or no? Let here is a fixed pulley, right? Here is a fixed pulley, getting? And here is a ring, right? Ring means that is also a pulley type, okay? And the thing is that it is connected like this, okay? यहाँ से एक rope आया और ये इस तरह गया rope, ठीक है? And it is like this, correct? A block is getting here mass m. Let the mass of this ring is m, right? And it is a movable pulley. That means if I will bring this block down, then obviously this will go up, right? Yes or no? If this block will come down, then obviously this small m or the ring will go up. All agree to that? Yes or no? And this is the total length of the rope, right? Let the length of the rope is L. Getting or not all? If this mass is m, this mass is m, right? Let the part of the rope length that is above the ring part is y, right? And the in gap between these two is, let in the question itself it is given, let this is d, and let this part is x, right? Means I'm considering this one because I want to relate something. What I will relate that is not given in the question. This part I'm just assuming, let this part of the rope length is y, and this part of the horizontal is d, and this part is x, right? Students, getting or not?
Yes, sir.
Then can you say me what is the rope length? What is the rope length? If I've given the dimensions, let rope length is L, but as per my dimension, as per our dimension that we have considered, this length is how much? Sisti, how much is this length? Y, right? How much is this length? X, right? Manashwini, how much will be this length, Semi? From this part to this part, how much will be this length? This is right angle triangle, right? If this is D, this is Y, then this length is going to be how much? D square plus Y square root over. All agree? Yes or no?
Yes, sir.
Okay. And the angle that is made over here is theta, right? Many things I'm going to relate. As per the question, we will take the assumptions. But I just want to show you this type of question can be also framed on this. This angle is theta, right? This is rope length, correct? Students, see here. If this block will, this ring, this M will go up, right? Then this will also come down, Hannah? Yes or no? Block will come down. All are able to understand or not? Students.
Yes, sir.
Then total length of the rope is going to be how much? Y plus this length, that is d square plus y square, right? Then plus x, yes or no? Then the total length is equal to how much? D square plus y square ka root over, right? Plus left side mein y, right side mein x. All understood this part? Everyone
Yes.
understood? Okay. So I want to relate the velocity, right? If possible, I will go to the acceleration. You will do that part. I want to find the velocity. How the velocity of this m, let that is vm, right? And let the velocity of this block is v capital M, right? How they are related? Yes or no, students? Correct? So see, this total length is remaining constant or not? Rope length is always constant. That is the main parameter for us, right? If I'll differentiate the rope length, that means dl by dt. If I'll differentiate, then I can differentiate like this, d by dt of whole thing I have to differentiate, right, students? Yes or no? Students. So that is
Yes, sir.
square plus, yes, this is d, this is y, right? So just a minute, see, just a minute, give me. Students, see here. Little bit modification we are making over here, like, student, this is the actually in the question that we're discussing. This is the mass m, right? This is the ring mass. Okay, student, if the ring will go up, let the rope I am considering from this part, right? This part is the rope length I am considering, right, students? This part, the red part, is the length of the rope that I am considering. This is y given. This is d. Then this length is going to be d square plus y square root over, right? Yes or no? And student, when this will go up, so this length will remain constant, right? That means rope length, if I'll consider from this part, because this is the rope is not connected from this part. It is just connected from the ring, right? And the ring is going upward. It may go up, it may go down. That will be given in the question. But I want to frame the things that is to be done over here. Getting that? So this y, we can take this y. Let's take this y, dy square, d square y, and this length. This y part you just cancel, okay? Then we can write the rope length is d square plus y square plus x, right? Yes or no? Students, getting that? What change I made?
Sir, can you explain?
Huh,
Can you explain again?
this is the ring having mass m, right? From here, let the rope is connected like this, and this is a movable ring, right? This is a movable ring. This is connected to the support. This support is not related. Let if the ring will move up or the move will down, then the block will go up and the block will go down. Yes or no? Correct. So the total length of the string I was taking y plus d square plus y square root over plus x. Yes or no? But see, if this part will go up, then this part will also change. D square plus y square and x will also change. Yes or no? Understood, students?
Yes, sir. Yes.
So this y part, I am just ignoring this y part. If from this part I will take d square plus y square plus x part I am taking, right? That is equal to rope length of the rope. Okay? Correct? Then here if I will differentiate both sides, then d square plus y square root over, right? Divided by dt. Yes or no, students? Correct? This is one derivative, then plus dx by dt. All getting or not? Because in the question he has given me the velocity of this m and the velocity of this capital M, right? Yes or no? Getting, students, understood?
Yes,
So many things we can do. We can find the tensor over here also, but he has not given, we are not concerned about this part. This theta will also change, because if it will go up, then it will be little more change, then the theta will also change, variable theta. At last we will see. Okay. Students, now you understood now how the length is connected. D square plus y square, this is y, this is d, this length is d square plus y square, and this length is m, right? X, right? Yes or no? Up to this understood or not? Say me, then I'll go next.
sir.
Go. See. After determining the length, our next aim is to differentiate it with respect to time, right? We want to differentiate dl by dt, and dl by dt is 0, right? Yes or no? And d by dt of d square plus y square, right? We want to find d by dt of d square plus y square, students. And derivative of d square by y square will be, students, half of 2y by d square plus y square to the power half whole into dy by dt, right? Plus dx by dt. Yes or no? Student, how this derivative came? Let's say, I'm saying, student, we want to find the derivative of d by dt of, we want to find d square plus y square, like this. It is written like this, students. Yes or no? This is function inside a function. Yes or no? Getting now? Student,
Yes, sir.
let
Yes,
let,
sir.
let will consider this part, d square plus y square part. Let will consider what? Let d square by y square, let t, let we're taking, no, t is there. Let take some variable z, right? Let z is equal to how much? D square plus y square to the power half. Yes or no? Getting or not, students?
Yes, sir.
Yes, sir.
So what we do, we always find dz by dt, right? What we do then? We find dz by dy, then we find dy by dt, right or not?
Yes, sir.
Remembering in derivative, I had taught those concepts.
Yes, sir.
Yes, yes,
So, so if I will differentiate this one, dz by dy, if I will differentiate, yes or no, then how much I will get? Dz by dy, let I am differentiating, because we want to find, just a minute, see here, we want to find this derivative. Okay, we consider d square plus y square is equal to z, right? Yes or no? You see, if I'll differentiate this thing, then it will be how much? The total thing will be z. Then that is d by dt of z to the power half. Yes or no?
Yes, sir.
yes, sir.
And we want to find, we want to write like this, dz by dt into dt by dy. But actually this is not required. We want to find d by dt, right? Then we have to write in that format, dt by dy. So if I'll differentiate dz with respect to z, then it will be how much? Half into z to the power half minus 1, na, students? Right or not?
Yes,
Then that is half into z to the power minus half. That is 1 by 2 into z to the power half, na, students? Correct or not? Understood, na?
yes, sir. Yes, sir.
And see here, half is there, right? You see, half is there. Here you have differentiated, half is there. Yes or no?
Yes.
Getting, na? And here z to the power half. Z we have assumed d square plus y square to the power half. So that's why d square plus y square half is in the denominator, right? See here. Yes or no? Understood? And inside y square is also there. Dy by d, if I'll make dy by dt, dy by dy, then y square derivative is how much? 2y, na, students? Correct? Yes or
Yes,
no? Then dy by dt is there outside, the extra part that we are multiplying here, dy by dt, that is multiplied again, right? Yes or no? Correct. Then dx by dt, right? So this dy by dt is what? Velocity of the small block, na, students? Yes or no? Ring, dy by dt is the velocity of the ring, na? Correct? Yes or no?
yes,
And dx by dt is what? Velocity of the block, na? Capital M. Yes or no, students?
yes, sir.
So let's replace that one. So we can write here that this one we want to replace. So I am writing that term again here. Then I will solve. Right? We got by differentiating dy by dt is equal to half into 2y divided by d square plus y square to the power half. Yes or no? And dy by dt, right? Plus dx by dt, right?
Yes, sir.
So dy by dt, this part is 0, na? Yes or no? So you can write, student, dy by dt is how much? Dy by dt is equal to velocity of the ring, that is small m, and dx by dt is equal to how much? Velocity of the block, that is capital M, right? Yes or no?
Yes.
And see here, if this is a right angle triangle, right? If this is theta, you know, if this is theta, this is a right angle triangle, right? This is a right angle triangle. Yes or no? This is a right angle triangle, that's students, correct? If this
Yes,
is
sir.
theta, then cos theta is equal to b by h. B is what? B is what?
Y.
Y. H is what? D square plus y square root over, na, correct?
Yes, sir.
So here you can write cos theta is equal to how much? B by h, that is y by d square plus y square root over, right?
Yes, sir.
Yes or no? Hmm? So here you have the 2 cancel, right? Here you can write y square by d square plus 2 to the power half. There you can write cos theta, na, right? Yes or no? And dy by dt you can write what? Velocity of the ring, Vm, correct? Is equal to how much? If that will go to that side, then that is equal to minus V capital M. Yes or no? Dx by dt is Vm, na? This one is Vx,
Yes,
na?
yes,
V of this is velocity of the block. This is velocity of the ring. And this is cos theta, right?
yes,
And student here, velocity of m is equal to how much finally? Minus velocity of block into cos theta. Na? If only theta will be given in the question, nothing will be given in the question. Yes or no? Actually, in the question here, he had given nothing. Only theta given, yes or no? And only velocity of the block or something given and asking what is the velocity. If you don't know this type of concept, then suddenly you cannot attend the question also. Getting or not? Students getting now?
Yes, sir.
If you
Yes.
again, if let sometimes in the question also, he may give what? He may also give the velocity m and cos theta also give. Everything will give and he will ask acceleration, right? How the acceleration will be related. Student, by differentiating this expression, you can also get acceleration of the capital M, right? Yes or no?
Yes, sir.
And velocity of the how changing, that is acceleration of the small m, right? Getting or not?
Yes, sir.
And derivative of cos theta you will see there. So student, you remember cos theta is not constant here. Cos theta is not constant. Cos theta is not constant, but it's variable. Student, why I'm saying all those things? Because somewhere you will get some type of questions. At least the minimum concept you should carry in mind before going to solve any question. Because from laws of motion onwards, yes, those who are feeling difficult, then you take your time, practice it again and again. Let me to come to you for making you understand, or you come here to understand something. Because you but you have to understand, yes or no? Students understood this concept? Students, see here.
Yes, sir.
See here. This is the, actually there is another string also. This is the string, this is the string, the red part. This is the string. Let the total string length is L, right? And here this length is X, right? This distance, let in the question is given, let Y. Yes or no? This is theta, right? This length I am not considering, because if length will be there or some pulley will be there, then also this length of the string is going to remain constant, right? Yes or no? And what is the length of the string? Semi L is equal to how much? This is d, this is y, then this is d square plus y square. This is also d square plus y square, right? Then 2 times of d square plus y square, right?
Yes,
Plus x, that is equal to constant, na? Yes or no? In the same way, if I'll differentiate, then dl by dt is equal to how much? 2 times, then 2 y will be internal, that will be differentiated and will be multiplied. Then rest will be assumed another function. If I'll differentiate, then that is 2 times of d square plus y square to the power half, as we did, okay, no? Then dy by dt, right? Plus dx by dt. This is the derivative constant concept. Just see how to differentiate with respect to a new variable, right? Because your d is there, y is there. I want to differentiate them with respect to time, right? No or not, student. Let y is equal to x was there. Once again, I'm saying about the derivative. I want to find dy by dt. Then what we are doing? We are writing like the dy by dx into dx by dt. We are writing like this, na? Y is a function of x, but we want to find dy by dt here. Y is not related to t, but I want to find this term by dt, right? Then what we have to do? We have to find how the dy is changing with respect to t, then dx by dt, right? In the same format, we are doing the derivative, and this is the result. Getting correct? And here 2 cancel, right? Yes or no? This dy by dt is what? This dy by dt is what? This is the velocity of this, na? How this y is changing. That depends on this velocity, na? Velocity of the fast block, right? Yes or no, students? How this y is going to change, that is going to decided by this fast block or not?
Yes.
This is velocity of the first block. This is velocity of the second block, right? And how the x is changing, that is velocity of the second block, right? This is velocity of the first block. From the diagram, you are able to see or not? This distance was x. Yes or no?
yes,
This block was y. See the video again and again, write the question, draw it of your own, then understand. It may take some time, but you understand this one. Yes or no? Because I'm giving you the hints so that any assignment, any level will be given. At least you have not solved such type of question, but the concept is there in the mind. Okay, write it in the copy. See here. So here you can see, I can rewrite this. 2y was there. So this is y by, that is also cos theta. Yes or no? See, y by this. B by h. Cos theta, na? Okay? So we can write 2v1 cos theta is equal to minus v2. Yes or no? Then v2 is equal to how much, students? Minus 2v1 cos theta. Can you relate the things like this? Students, understood this one? Understood or not, Semi?
Yes, sir.
See, in this question you had given rod of length L, right, is inclined at an angle theta with the horizontal, you can see here, right, against a small vertical wall. Student, if let this is point एंड रॉड ए का इस एंड का नाम ए दे देते हैं, इस एंड का नाम बी दे देते हैं, ठीक है. इट इज आस्किंग इफ समटाइम्स ड्यू टू सम रीजन द साइड ए एंड, मतलब स्लाइड्स होता है ये वी ए में साइड होता है नीचे की तरफ, वी वन में लेट, ये सब नो. At what velocity the VB, if it is coming down, then definitely it will go in this direction. Yes or no? Student, when the rod slides along the wall, then it will go in this direction or not? If A is coming down, right?
Yes.
Then this the B block will go rightward, right?
Yes.
Yes, sir.
He's asking what is the relation between this is V1 and VB, right? Correct. Student, let the initial distance between this was Y, right? Yes or no? And the initial distance between this is X. Correct or not? Initially, from the starting condition, right? So here you can say length of the string, that is L rod, that is L square is equal to X square plus Y square, we can say or not? Yes or no?
Yes, sir.
So how the X and Y will change? That will give me the velocity, na? Yes or no? How this Y will be decreasing and the X will be increasing? How that, if Y will decrease, then X will increase or not? Student, ये साइड नीचे की तरफ आ रहा है, तो ये भी आगे की तरफ जा रहा होगा ना, करेक्ट और नॉट? And this is the relation, correct? And length of the rod is constant. I can differentiate dl square by
Yes.
dt is equal to d by dt of x square plus y square. Can I write? Yes or no? And the length of the rod is constant, so this is going to be 0. So that is equal to how much? dt by x square. How much will be, student? D by dt of x square. That is 2x of dt by dx, na? Correct?
Yes.
So not dt by dx by dt, right? 2x by dx by dt, na? Yes or no, students? And plus y square is how much? Dy by dt, right? 2y, that is also
2y.
2y dy by dt. Students, remember or not? We want to find dt by dx of x square, right? Yes or no?
Yes.
We want to find dt by dt of dx square. Then what you have to do? We take y with different function x square, let y. Yes or no? That means we take let y is equal to, not y, let z is equal to x square, right? What we do here, differentiating with respect to a variable, d by dt of z, right? We want to find. Then we can write here dz by dt into dt by dx. Yes or no? Like that, function inside a function. Do you remember that part or not? Derivative. So this is x square is 2x dx by dt, 2y dy by dt, correct? And friend, this dx by dt is what? Velocity of what? Second, na? How x is changing? That is v2, right? And what is dy by dt, students? v1, na? Correct? Yes or no?
Yes, sir.
Correct or not, students? Then you can write here, see, 2x, we can write 0 is equal to 2x into what? Dx by dt matlab velocity of v2, right? Plus 2y into v1. Yes or no?
Yes, sir.
Both side 2 common, cancel out. Yes or no? We can write x of v2 is equal to
Minus yv.
y of, see here, minus, yes, correct. One thing I would like to say here. Students, see, Students, this X value is increasing, right? V2 is increasing, right? Yes or no?
Yes.
But this Y value is decreasing now with time. So that is a negative function. Yes or no?
Yes.
So you can see here that this, see here. So we can write X V2 plus Y of minus V1 because it is decreasing is equal to 0. Yes or no? So V2 is equal to how much? Y by X into V1, na students, correct? Yes or no?
Yes, sir.
Yes, sir.
If this is V1, Y by X from the diagram you say me. If this is Y, this is X, then tan theta is equal to Y by X, na?
Yes, sir.
So the correct statement about the rod we can say that is V1 is equal to how much? Sorry, V2 is equal to V1 tan theta, na, right? We can say or not? Hmm?
Yes.
Right, in constant, let's see another equation. Let this is a support, right? From here there is a fixed end. Here is a pulley, movable pulley, right? And the string is going like this, correct? Here is a fixed pulley, right? This one is the fixed pulley. Again, a block is connected like this. This is M1. Here is also another plug connected M2, right? If tension, I will give this is T, this is T, this is T, right? Yes or no? Students, see string length. I am saying about string length. This is the length of the string, na students, correct? Yes or no?
Yes, sir.
Yes.
I'm taking two labels here. See, this is the label, this is the label. Yes or no? In between this, because this part is common for both and this part is common for both, right? Just is pulley connected, this pulley length I'm taking. The part of the string this side is students L1, let, yes or no? Let L2. And the path of this part of the string that up to this is how much students? L1 let, right? Yes or no? Students, seeing or not? I'm taking this label and this is the label that will change. This label will also change. Yes or no? This end is fixed, right? This end will change and this end will also change. Yes or no, students? Getting na?
Yes, sir.
So see then, this length is how much? L1, right? If this length is L1, then students see here from this mean position, this length will be also how much? L1, na? Right or not?
Yes.
And I'm taking this part of the length, correct? Because this is common, this part is common. Just I'm taking from the reference point. So here you can see this side 2L1, right students? 2L1 plus L2 is equal to constant, na student, length of the string, right? I'll make you by giving many examples how to relate such type of relations by seeing the and many number of pulleys connected. Initially, I'm not giving because you do some questions, you just get face difficulties, you try to know how it is becoming. Then I will give you the last trick. Okay, students, see here. This part I am
Yes.
again. I'm saying this part. See this length. Okay, this length is L2, right? And this length is L1. This length is L1. Yes or no, student? Getting or not?
Yes.
So from the equation only you can see 2L1 because this row, this two side 2L1 plus L2 is equal to constant, right? So from there, if I differentiate, I can write what?
Yes.
So 1 minute, students. I have interchanged the thing.
Excuse me.
Yes, just give me 1 minute. I have interchanged the thing.
Yes.
Student, this side we have taken as L1 and this side we have taken as L2, right? This is the total length. That is 2L2, right or not?
Yes, sir.
This length.
Yes, sir. This is
Yes, that was the mistake you have made. Just don't worry. Just see. This side we have taken as L2, right? And this one we have taken as L1. So this L1, this is L1, right? And you take this part and this part. That is what is the length of the string? That is L2, na?
L2.
So this total length of the string, ये वाला length और ये वाला length मिला के कितना हुआ? 2L2, na? And this is L1, right? So you can write L1 plus 2L2 is equal to 0. Correct? Now understood all?
Yes, sir.
So if I'll differentiate the displacement, velocity v1 plus 2b2 is equal to 0, right? a1 plus 2a2 is equal to 0, right? Now, is there any requirement of knowing the loosening and the tightening concept? Students, seeing the pulleys, you can say, seeing the length of the string that will remain constant, by differentiating it, you can say how the velocity and the acceleration will change, right?
Yes, sir.
Understood, Manish? Let's see next. Another example, just I'm saying the last part. Okay, 5 minutes is there still. See, it is a support like this, correct? इस तरह की एक सपोर्ट है, यहाँ पर एक ब्लॉक रखा हुआ है जिसका मास m1 है और यहाँ पर एक पुली लगा हुआ है, ये ऐसे आया ऐसे, ये फिक्स्ड पुली है, राइट? और यहाँ पर एक मूवेबल पुली है, राइट? और यहाँ पर भी एक ऊपर में एक फिक्स्ड है स्ट्रिंग और ये ऐसे जा रहा है, राइट? करेक्ट? ये एक ही स्ट्रिंग है ना स्टूडेंट्स, करेक्ट?
Yes, sir.
जो मैं ब्लू पे बनाया हूँ, मतलब देख सकते हो यहाँ पर जो मैं ब्लू पे बनाया हूँ, दैट इज द स्ट्रिंग, राइट? दैट इज द कॉमन स्ट्रिंग. इस स्ट्रिंग को लेके हम लिखेंगे, ठीक? और यहाँ पर एक ब्लॉक लगा हुआ है m2, राइट? इक्वेशन तो आप बना लोगे एक बार, एक्सीलरेशन मिलने के बाद इक्वेशन बनाने में कोई दिक्कत नहीं है, राइट? tt 2t, this is 2t, ये सब. Student, see here how to deal this question. Student, let this length is L1, right? Yes or no? And from this to this length is how much, students? L2, right? Getting or not? You can take this label also, no problem. This label to this label, you can take L2, no problem. But I'm saying because that is not a big difference. If this is L2, this is also L2 ना students, correct? यहाँ से यहाँ तक L2, यहाँ से यहाँ तक लेंथ L2 है ना? इस लेवल से मैं
Yes,
बात,
sir.
ये सब. और ये वाला लेंथ भी चेंज हो रहा है L1, करेक्ट? सो टोटल लेंथ ऑफ द स्ट्रिंग कितना हो गया यहाँ से यहाँ तक? L1 plus 2L2 is equal to 0 ना? Is equal to constant ना, right? Yes or no?
Yes.
As you got directly, you can write A1 plus 2A2 is equal to constant. Yes or no? That means if this is having L1, that means this is having acceleration and A1, then this will having acceleration how much?
2 8.
2A2, right? Getting or not?
Yes, sir.
So by solving now, you can find how much, if it asking how much is A2, how much is A1, you can find by solving the equations, by putting the equations, okay?
Yeah.
Understood. Just see once again this thing.